Okay. Hi, everyone. Welcome to Femafric. Okay. My name is Edem, and today I would like to take you through set theory, what a set is. Um, in one way or the other, we all have come across what a set is, but maybe you've not realized it. Okay, let's take this example. Let's say, sorry, when you go for shopping, let's say shopping, and then when you enter the hall, the shopping mall, or the supermarket, you realize that the items over there are arranged in such a way that you will not suffer to get what you want. That's set. They're actually using set theory to group items. And also in our kitchen, your wardrobe, your everywhere we use set. Set is basically grouping items or objects which has, let's say, common features or common characteristics. So we are coming to learn little thing about sets, and then we solve 2 or 3 questions, and then I think that will be good for the day. So set is a collection of items. So when you ask what is a set is a collection of objects with a common features or characteristics. So we do set to help us to order our things easily. Like when you have a lot of, let's say, songs in your smartphones or your laptop, you cannot just put everything together. You have to group them. Mostly we group them so that you know which one is rock, which one is reggae, which one is gospel songs. So in that domain, we are basically practicing what a set is. So we are presenting it more in mathematical way so that life will be much simple and easier. So set theory is not anything from Jupiter or something, it's whatever we do every day. Okay, so this is set. A set is a collection of objects with a common features. And then let's say name of animals. So you start listing. So this is what we use to represent sets. A group of animals. Curly brackets. Let's say dog. Dog is an animal. Cat. Let's say fowl. So you keep on listing and you will list the set to some number. That's why we can't exhaust our list. So what we do is we represent it with 3 dots and then you close it. So this is actually a set. So basically we could identify that all these things are what? Animals, a name of an animal. So therefore it's a set. But when I include the same set, let's say I have this dog, cat, and let's say pen. This is no more a set because it is not well ordered. We have pen here. Pen is not a name of an animal, unless maybe we define pen to be a name of an animal. So the set is a collection of objects or items, and those items are called elements or a member of a set with a distinct future. So if, let's say we have this is an animal, cat. We all know that cat is an animal, dog is an animal, pen is not an animal. So this particular thing disqualified to be called a set. And like arithmetic, like adding of numbers and other stuff, set also has some operations that we use in set. So I would like to take you through some operation of set and then some um, examples. Okay, so now let's move to operation of a set. And one thing is we normally use um, capital letters to note a set. Let's say A, B, C, or whatever is a set. We use capital letters to notate or to represent a set. And then small letter, we normally use small letters for elements. Say X, Z, or anything. We use those small letters to represent elements. So let's look at some um, type of set. Say type of set. Before we come to the examples or the notation type of sets. The first one I will talk about is a set that contains everything, like the whole set, the whole element, like everything in aggregation, like our space that we are working in. So we have what we call universal set. It contains everything, universal set. This could be, let's say a music in your phone or songs. So all the songs, when you put them together, becomes your universal set. Any song at all, whether reggae, whether hip hop. So far as it's a song, when you put them together, we call it a set that contains everything. Example can be a set of integers, either positive or negative, a set of integers, a set of odd numbers, and then you can state or you can list and list and list. We have a lot of examples of universal sets. So a set that contains what we are considering is what you call a universal set. And then second one too, we have something what we call subset. Subset is like derived from the word sub. Like sub means some division, like sub. So let's say we have this. We have a whole of this to be our space. Let's say this is our classroom or our school. Let's pick a school as example. So this is your school. And let's say this is your junior high school. Then you have junior high school, you have Form 1, you have 2, those in Form 3. So adding Form 1, Form 2, Form 3 together, then you have a school. And then when I am focusing on one particular group, let's say this, then when I pick this one, this Form 2 is a subset of the whole of this, the universal set. So the issue is a subset. When you have a subset, let's say A, and then you have some bigger sets that you are picking that set from, let's say B. Then we say that A is a subset of B. That means all elements, all members of A can be found in what? B. If the element in A are not or is not in B, then it ceases to be a subset. So we denote subset as this. We have this one, this symbol. So this is a symbol for a subset. So it means A is in B. Let's say that, let me give you this example. Let me write this numerical example so that you will get the understanding better. So let's say we have 1, 2, 3, 4, 5, 6. And I decide to pick, let's say, this group. This is a set of A. This stands for A. And then this big label of B. So you can see that A is in what? B. So when I list, let's give this picture. So A, what are the elements of A? This is the set A. So you have 1, 2, 3. So we have this 1, 2, 3. So these are the elements in A. And then let's list the elements in B. We have B is the whole of this. It's not this. This is B. The whole of this space is B. So let's start from 1, 2, 3, 4, 5, and 6. So now you could say that this set is B, this is A. So we say A is a subset of B because A is in B. You could say that this is 1, there's 1 here, 2, 2 here, 3, 3 here. That makes it a subset. If I include this, let's say 10, then 10 is not a subset of B because the element 10 is not in B. So that's what a subset is. You have to make sure that the element in your A should be in the element in the other set as well. So that is basically a rough idea about what a subset is. Okay. That's basically, and then you have what we call empty sets. Empty. Empty set. As the name goes, empty. There's nothing in the set. We have nothing in the set. And then we use this one. Empty set. This one. These are the notation. Curly bracket without any element or a 0 and then you cross it. So when you see something like this, it's an empty set. Okay. Let's say, okay, let me give you one example of empty set. Yeah, empty set is empty. There's nothing in this, but we'll come to that as well. And then the other set, and then the other set. Okay, so basically, I would like to show you these 3 types of sets, and then we will come to some notations and some other properties of a set. Okay. So notation. This notation of a set. The first one, you've come across it, this curly brackets. These are curly brackets. We use it to represent what a set is. So when you see something like this, and some elements separated by commas, it means it is a set. So we use curly bracket to represent a set. So these are curly brackets. And then the next one is this. We have this U, which represents universal union, a union of the sets. Union of the sets. What does it mean, a union? Union, putting things together, union. In arithmetic, we may say it's addition. You're adding the elements in the set, but we are not adding as 1 plus 1, but we are putting the elements in both sets into one common set, like into one set. Let's say we have A to be our set. We have this. We have cat, dog, and say hen. This set A, and then set B We have what we call anything. Let's say book. Okay. Let's say lion and tiger. Let's say we have only two elements. And then we are finding the union of these sets. It means we are putting them together. So what we do is A union B. We have cat. We have dog. Then we have hen. We are done with this. And then we move to this one, lion and tiger. So these are the union. You are putting the elements together under one set. That's what we call a union. So the union means the elements are either in A or in B. You see, when you look at this cat is either in A or B. And you can see that the cat is in A. Dog is either in A or B, and you can see that the cat is in A. Hen, the same thing. Lion is in B, and then tiger is in B. So the union is either the element is in A or in B. So sometimes we'll come across some word problem, and then we'll tell you the element is either A or B. It means they are in both, either one of them. Okay, so let's look at the intersection. Intersection of the sets. Intersection means what intersection implies is, let's say we have two sets, A and B. We are trying to look at what are the elements or what are the elements that appears in A at the same time appear in B. So we are looking at some common elements that appears in both sets if you are dealing with two sets. So let's say we have this set. A equal to 1, 2, 5. And then B, we have 10, 12, 13. Ask yourself, is there any common element in both sets? So you check. You have 1, 2, 3. But when you check this set, there's no 1, there's no 2, there's no 3, 5. Sorry, this one's 5. So you can see that the intersection between A and B is what? 0. And what do you know about 0? That means the set contains nothing. There's nothing in it. And then we use this to represent it. Empty set. Or a curly bracket without anything in it. This means the intersection is what? Empty. There's no element. Okay, let's look at this as well. Let's say you have C equal to 3, 6, 9. And then you have D equal to 6, 12, 18. Then you're asked to find the intersection, the common element that appears in both sets. You have 3 here, there's no 3 here, so you move to the next one, 6, then you have 6, so you put it down, you have 6. So this is the notation for intersection, this one. This is the notation for intersection. So you have A, C, intersection D is equal to, then you bring your curly brackets. Sorry, I'm not good in drawing curly brackets. So you have 6, then you move to the next one, there's 9 here, no 9, then it's okay. So this is so you have 6 as an intersection here. Okay. Now let's move to another one. So we have the union, putting elements together. We have intersection, finding the element that appears in all the sets. And then now let's move to what we call complements. What we say complement, it means you have, say, a universal set. So let's assume that this is our universal set. Say 1, 2, 3, 4, 5, 6. So what can you say about this set? When you look at this set, you will see that it's a set of what? Positive numbers or positive integers less than 7. So 1 is a positive number, 2 is a positive number, 3, like that. And then you have, these are universal sets. And then you have these two sets. Let's see, A. You have A to the 4, 5, and 6. And then we are trying to find A complement. A complement. A complement. A complement means elements that appears in the universal set, but they are not in A. Element that appears in the universal set, but you can't find them in that particular set. That's what we call complement. So when you look at this, you could see that 4, there's 4 here, 5, you have 5, and then 6, there's 6 here. So it means these three numbers are not in A, but they are in the universal set. So that's what we call complement. And then we use this one to note complement. Some use prime, you can use prime or this, then the set. So we have A complement is equal to the elements that are in the universal set but not in A. So we have 1, 2, and 3. So the complement serves as subtracting elements in the universal element in the set from the one in the universal set. The left out are the complements. And then back to intersection. Intersection means end. It means the elements are in A and in B. That's one thing about it. And this one is common. The element that appears in A in the universal set but not in A. These are what we call the complements. Okay. I think that's okay. And then I would like to introduce some other notation as well. Sometimes they'll give you a set, a list of items, and then they'll ask you which of these is a member or an element, and which are not an element. You want to know which one belongs to the group, which one does not belong to the group. And that, we have a notation for that, element of a set. We denote it as this. C with a cross. This one, an element. So when you have a set like A equal to 1, 2, 3, 4. And then you want to know whether A is 4 is an element of A. So if 4 is an element of A, then you have 4 is an element of A. This means 4 is an element of A. 4 is an element. The difference between elements in a subset. A subset is you are considering a set that are in that set. But an element is one or an element is like any object in that set. When you pick them individual, that is element. It's not a set. So 4 is an element of A. So let's check. Is 5 an element of A? No, 5 is not an element of A because we can't find 5 over here. So how would you write it mathematically? So you write 5 is not an element of A. 5 is not an element of A. So I'm just giving you this concept so that when you have any problem on set, you apply them and then you solve and you are good to go. Okay, I would also like to introduce one more thing, um, which we call equality of a set. When you say set are equal, what does it mean? So we have equality of a set. Equality of a set. When you say two sets are equal, let's say I will still use our normal set A and B. And then we have A to be equal to 2, 4, 6. And B is equal to, is a set of, let's say, even numbers less than 8. So when you look at this, you can see that this is actually even numbers less than 8. And then this one is also even numbers less than 8. So when you list the element of A and then the element of B, you can see that A has the same element as B. Then we say A is equal to B. It's not about the number of elements. Let's say this one has 3 elements, the other one has also 3 elements, but different. It's not about that. Let's say this one. Let me give you this example. Let's say we have A equal to 3, 10, 12. And then B, 3, 10, 11. A is not equal to B, though they have the same number of elements, 3 elements, 3 elements. But when you check, you have 10 here, 10 here, 3 here, 3 here, 10 here, 10 here. But this one we have 12, and then this one 11. They are not the same. So it's not equal. So when you talk about equality of a set, it's not about the number of elements in the set, but as I mentioned, when the element here, this one is even number less than 8, and then this one is even number less than 8. So when you list the element in B, you will see that this one is actually equal to this. And one thing about set is, it's not always that they will give you numbers A, B, A, 1, 2, 3, 4. Sometimes they will ask you in a word problem a list of, let's say, integers, positive integers less than 10, greater or less than some limit, and then they ask you to find the intersection. So I will be giving you more example about such problem. So you have to also know your number system, what integers are, even number, prime number, and then odd number. So they'll ask you set questions. So you should be good at your number system. So you can revise as you are seeing the house. You can still go through your number system and look at what even numbers are, what odd numbers are, so that when you see any question on the stage, it will be very easy for you to solve. Okay, so let me give you some practical examples, some examples of what we've gone through now, and then see how it works. Okay, let's say example 1. Example 1. I have my universal set to be equal to list of let's say even numbers. Okay, that's fine. Let me get all positive integers less than say 12. And then these are our sets, other sets, the subsets. So we have A and all prime number or all prime numbers less than say 30, whatever. And then you have B, our second set. It's also a list of say odd numbers. So all odd numbers. Odd numbers. It's also less than or equal to say 12. So these are the problem. Then let's say you ask, find one. Find A union B. I. Find A intersection B. So when you have set problem, then you have to know what your universal set is first. So to solve this, you ask yourself, the universal set is that list all positive integers less than 12. So first of all, if you don't know what a positive integer is, I don't know what you are going to write, because when your universal set is wrong, it means all other sets or your answer might be wrong. So you have to take note what positive integers are or what an integer is. So basically, integer is any whole number, either positive or negative, any whole number. So you have u to be, what are positive integers? Start from, some say 0, so let's include 0, 0 is part of it. We have 1, 2, 3, 4, 5, 6. This 3 dot mean it continues to, then what, less than 12. That means 12 is not inclusive. We don't include 12 because 12 is a part. So we have 11. So this becomes our universal set. Now we are done with our universal set. So what next? Then next then is a set of all prime numbers less than 30. So you ask yourself, what are prime numbers? What are prime numbers? So prime numbers or prime number is any number that has just two factors, 1 and itself. So when you pick 2 like this, what are the factors of 2? You have 1 and 2. When you pick, let's say 3, what are the factors of 3? We have 1 and 3. It means 2 is a prime number, 3 is a prime number. Let's pick 4. You have 4. What are the possible factors of 4? When you say factors of a number, they are numbers that can devise that number. So 3 can devise 3, 1 can devise 3, So you have 1. 1 can divide any number. And then 2. You have 2. And then 4. You can see that here you have more than what 2 factors. So 4 is not a prime number. So that's basically what a prime number is. So now let's move to our main objective. Let's move to our main objective. So our set A now becomes, is 1 a prime number? No, because 1 has this 1 factor. So 1 is not a prime number. Let's keep 2. 2 is a prime number. 3, 5, 7, 11. But why not 13? Who can tell me why not 13? Because 13 is also a prime number. But our problem here says a prime number less than 13. So 13 is not part. So we list up to 11. Then we stop over here. Then we close our bracket. We don't want any other element to enter. So we have to close it. So we have B. Let's move to B. B is what? All odd numbers. All odd numbers. So what are odd numbers? I hope you know what an odd number is. So 1 is an odd number. 3 is an odd number. 5, 7, 9, less than or equal to 12. But 12 is not an odd number. So we stop over here. So now you have your elements, your sets, and then various elements. And then you come back to your question. Find A union B. This sign is what we call union. Union means you are putting the element together, not necessarily adding them as arithmetic for. No, we are just putting them together. So we have A, this I, union B is equal to, you can either arrange it in ascending order or anyhow. So you have 1, then you have 2, 3, you have 5, you have 7, you have 9, you have 11. So this A union B. Someone will ask, why not 5, 5? Why can't we write 5 twice? Per our definition, we say set is what? A collection of objects with a distinct feature. And then those elements should be distinct. So when you have something like A equals 1, 1, 3, this is not a set because we have 1 repeating itself. So when you have this, you just write 1 when it repeats itself. So 5, 5, when 5 repeats itself, or we have double of, we just write 1. So that's how it is. We are just putting them together. This one is not part of it. I'm just like stating that. So you put these 2 elements together. Okay, let's move to second example. Find A intersection B. Find A intersection B. So it means element that appears in A at the same time in B. So you ask yourself, go back to your set. What are the elements that appears in both sets? The first one that comes to mind is when you look at the set, we have 2, there's no 2 here, there's no 1 here. So 3, you have 3, 3. So you have your 3, 5. There is 5 here. So you have 5. There is 7 here. So you have 7. There's no 9. And then you have your 11. So this is what we call intersection. 3 appears in both sets. 5 appears in both sets. 7 appears in both sets. And then 11 appears in both sets. So when you see an element appearing in both sets, then we call those sets or as intersection. Okay, so this is just one example of it. This is just one example, and this one mostly comes in section 8. So we just Um, read quickly and then you know what you are going to read quickly. Okay, let's move to another example. Okay, example 2. We have this. As usual, our universal set to be 0, 2, 4, 6, 8, 10, 12. And then A to be set of all positive integers, positive integer, or positive integers less than or equal to, say, 12. And then you have B equal to set of all even numbers. Set of all even numbers less than 6. Okay, so looking at this, we can ask a lot of questions on this. Let's say, first of all, let's list the element. For this universal set, we have, let me ask, first of all, find A union B, all prime. I find A union B intersection, say, you have only 2 sets. You have only 2 sets. Yes. Okay, so let's pick up this quickly and then move to next topic, right? Next subtopic what to do. So A union B. So we have our union to be that. This I mean I would not like to repeat the same thing. So let's start with A. So A have this element. Positive integers, we know what an integer is. So we have 0, 1, 2, 3. So A is actually the same as we have. I think I have to change the question a little bit. Positive integers. Okay, let me change the question to 1. I want to change the question to 1. Positive integers divisible by 3. Divisible by 3 and positive integers. Sorry. And less than, let's say, less than 12. So it's positive integers, that's less than 12 and then divisible by 3. So what are they? It's just the multiples of 3. So you have 3, you have 6, you have 9, less than 12, right? So this set A. And then B will give us something like a set of all even numbers less than 6. So you have 0, 2, and 4. And then the question goes like this. Find A union B all complements. So this one is just like normal arithmetic operation. So we will deal with what is in the bracket first using board mass. So first of all, let's find our set A union B. So what is our A union B? So A union B, we are putting all the elements together in both sets, right? So we have 0, we have 2, we have 3, we have 4, and 6, 9. So this is our result. 2, 0, 2, 3, 4, 6, 9. And we have to find the complement of this set. And then the complements are a set that appears in the universal set but not in the set of this. So now A union B all complements becomes, so you subtract all this from the universal set. The remaining is what? The complement. So we have 0, 0 here. So you can cancel out 0. 2 appears here. It appears here as well. There's 4 here. There is 6. Cancel out. There's no 9. Sorry. And then the remaining is the complement. So we have 8, we have 10, and then 12. So the complements are element that appears in the universal set, but not in this particular set. That's the idea about complement. And then the next one, well, I think this one you've already found it, so it's okay. A and B, which is what it is. Okay, so that's just by the way. So let's move on to other sections. Okay, writing all this union, this set, someone decided to put all this in a nice way for us. A certain man on Venn. So we have something what we call Venn diagram. So he simplified everything and then put it in more concrete way for us. That makes life more simpler. So we have what we call a Venn diagram. So I would like to introduce to you what we call a Venn diagram. I hope you're okay with the intersection, the union, and other stuff. So when you get your past questions or anything, you can see a lot of this. Find the intersection, find the union, the complement, and other stuff. That's basically what we found for now. So Venn diagram It's not anything new. It's just that's what you are doing. We are trying to put them to more concrete way in a diagram form. Let's say we have this. This is what we have. And then the whole of this is what we represent as our universal set. The space as which we are considering. So we have this to be a universal set. So we normally represent it as this. Then the U. That's our union. And then the various subsets, the various groups are in it. So let's say this, a total of, let's say this, anything, a set of, let's say positive integers or negative integers within some range. Let's say positive integers within some range. And then we have our various sets. But this one, I will limit you to just two sets problem. So we have this second set. Say A. Let me label this one as A. And then this one, let me label this one as B. So what can you say about this set? When you look critically, this is our whole region. And then let's say we have 1, 2, 3. And then this place, let's say, this one. Let's say the union is this set. Let's say 1, 2, 3, up to 10. Let's say our number is up to 10. And then in set A, we have something like 6 and 7. And this one, say 9 and 8. And 10. So the whole of this is our universal set. 1, 2, 3, 4. Let me put 4 over here. 4. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The whole of this is our universal set. And then the elements in A are 6, 5, 7. And that of B, you just list them. That of B is this. We have 1, 2, 3, 4. And what about this? Well, these guys are not part of these two sets. Who can tell me what 10, 9, and let's say 8 are? Okay, we'll come back to that. What can you say about this A and B? Now, let's look at this A and B. So let's try to find the union. The union will be A 1, 2, 3, 4, 5, 6, 7. So you have 1, 2, 3, 4, 5, 6, 7. And then the intersection of A, intersection B. What will be the intersection? Let's check. Is there any element between these two sets? Any common element? No, there's no common element in these two sets. So what do we say? We have empty sets. So when you have empty set, then there's no intersection between two sets. Then we call it a disjoint set. So A and B are what? A disjoint set. That means there's no element in common. There's no element in both sets that are common, right? You have common. So this one is actually a common disjoint set. Okay, let me give you another example. So this one is disjoint sets. So it's also another form of set. disjoint set. That's where the intersection of the two elements is an empty set. When you have intersection to be an empty set. So let's consider this example as well. So you have this and this. Let's say the first one is of A, this B. So the whole space is a universal set. And then you have this. So what are the elements of A? So first of all, you list all your elements of A. So we have 1, 2, 3, 4. And then element of B. This is a set of B. So you include everything in B. So you have 3, 6, 7, 8, 8, and 9. So when you put them together, then you have the whole of this to be the union of the two sets. Now let's find the intersection. The intersection between the two sets. So when you look at the diagram, the intersection is this region without you even listing the element, then writing down the element. So this shaded region here is the intersection. So you could see that you have 1, 2, 3, 4, 3, 6, 7, 8, 9. So when you want to find the intersection, the common element, you could see that 3 appears in both sets, right? So this region in the Venn diagram is what we call intersection. So this is the intersection part. So this is where you have an intersection. And when you look at this region, this particular one, this one is shaded like this. Different color. When you look at this, this one is what we call A only, without including any element from other sets. Only A. So when you look at this particular set, when you remove the intersection from A, then we have A only. So this one is for A only, for A only region. This is A only. And then obviously B only will be this, excluding the intersection. So this one is B only. B only. So let me write this one. We have A only. We have B only. So B only is when you remove the intersection part of it. See, when you remove 3 from this set, it becomes B only. This one, when you remove 3 from it, then it becomes A only. And then when we say A and B, as I stated earlier, A and B means what? Intersection. That element appears in A at the same time B. So A and B means intersection. Intersection. Okay. And then we have A or B. A or B. It means the element appear either in A or B. So when you see something like A or B, it's the same as find the union, like the element appears in here. So A or B is what? The union. Actually finding the union. Union of the set. So it means the element is either it's in A or in B. And I think the last one is this region. This means 5 is not in A, at the same time not in B. 10 is not in A or is not in B, but is what? In the universal set. So what comes to your mind? The elements, they are in the universal set, but they are not in the subset. So that comes with what we call the complement. So when you put all these elements together, A union B, you have the whole of this region, but these elements are not in. So A union B complement will be this element. So A union B all complements from this Venn diagram will be this set 5 and 10. That's this region. Because when you put this A and B together, it becomes one set, which is A union B complement. And then, which is A and union B. And then the complement of that means the elements are in this set. They are in the universal set, but they are not in this set. So these are the elements. 5 and 10, they are in the universal set, but not in the union of this. So basically, that's all about Venn diagram. When we say universal set in the bigger space, A only, we are talking of this region, B only, we are talking of this region, excluding the intersection. And then A union B complement means when you put all the elements in this set, and such elements, we have another element that are in the universal set, but not in the union of those sets. So this basically what a Venn diagram is. So Venn diagram is just the representation of what we did earlier to put things in a more compact way. Okay, so I hope you are okay with the Venn diagram. So we can take some possible examples that you can use at the end of your final exams. So let's take some examples on Venn diagram. So you have this. Example 1. Let's say I have this as my Venn diagram, as my universal set. U set is anything, you can represent it with either square or circle, it doesn't matter. So let's say this is my set. I have 4, 5. I have say 8. You have 1, 2, 2, 3, 6. And then here I have 7, 9. And then this place I have 10, 11. So this is our universal set. So now the question is, 1, find this A, this B. Find A intersection B. Since you know that what the two sets mean, the region is intersection, you don't need to even waste your time listening and canceling things. You just check. This is a region for intersection. So what are the elements out there? So you have 7 and 9. So you write out yours. answer 19 years. Could be between 7 and 9. 7 and 9. Okay. What other questions can we get from this? So you ask, find the number of, find A only. So what is A only? A only. A only. That means this grading. So the next question is the I. Find A only. Element in A only. So A only means we are excluding the intersection part and then we the rest of A. So this region is A only. So what is A only? We have 1, 2, 3, 6. So our A only becomes A only is equal to this 1, 2, 3, 6. Right? So next one is your B only is this. Your B only is this already. And then A intersection B. Sorry, A union B complement. So this one is also just like the board mass. So we first deal with what's, forget about the complement for the meantime. So first of all, find your A union B. So what is your A union B? So your A union B is actually you are putting everything together between these two sets, not the one outside. So we have 1, 2, 3, 4, 5, 6, I think 7, 8, and 9. So these are our A union B. But the thing is, you have complement. So now you introduce your complement. So this one becomes your new set. So what is the complement of this particular set? And you say complement are the elements that appears in the universal set, but not in this particular set. So you look back to your universal set. Your universal set is a whole of this. A whole of this. So you have one will cancel there, two is there, three is there, 4. All these are there. But what elements are not there? You could see that there's no 10 in our union and then 11. Therefore, our A union B, all complement is 10 and 11. That's why this region, this particular region, is what A union B complement. So we'll be using this to solve a lot of word problems. Sometimes they will not tell you A, they will not say B, they will say something, a number of students reading this course, like you will come to that. But this is the idea behind what a Venn diagram is. So when you understand this, then you can solve any problem in Venn diagram. You can solve any problem in Venn diagram. Okay, I hope you are good with this. You can continue. Okay, so I hope you are fine and I think you are following me. And please, if you have any question or any misunderstanding, you can drop a comment over there and everything will be fine. Keep practicing. Math is all about practicing. You be doing some mistakes, you go back and then you correct it. Without practicing, you might think you are okay, and then when the D-days, then you'll be doing some mistakes and other stuff. So please, if you are confused or anything, please, you can drop your comment and we are always available to help you out. I think next week we'll be doing something more on word problems and then solve more questions on sets. Okay, thank you very much. See you next week.